The topic for Lesson 10.2 is angles and arcs. You'll recognize major arcs, minor arcs, semicircles, central angles, and their measures. And you will find out how to find arc length. What kinds of angles do the hands of a clock form? Most clocks on electronic devices are digital, showing the time in numerals. Analog clocks are often used in decorative furnishing and wristwatches. An analog clock has moving hands that indicate the hour, minute, and sometimes the second. This clock face is a circle. The three hands form three central angles of the circle. In Chapter 1, you learned that a degree is 1/360th of the circular rotation about a point. This means that the sum of the measures of the angles about the center of the clock above is 360. Each of the angles formed by the clock hand is called a central angle. A central angle has the center of the circle as its vertex, and its sides contain two radii of the circle. The sum of the measures of the central angles of a circle with no interior points in common is always going to be 360 degrees. For our first example, they ask us to find the measure of angle RTS. Well, the first thing we have to do is find x. And we can see that RV is a diameter, so that means that all of these angles must add up to 180. So if we combine our like terms, 8x plus 13x is 21x, plus 5 more x is 26x, and -4 minus 3 is -7, plus 5 is -2. That's a lot shorter. Add 2 to both sides. So 26x equals 182. And if we divide both sides by 26, we get x is 7. And they wanted us to find the measure of angle RTS. So RTS was 8x minus 4, so 8 times 7 minus 4 is going to be 52. Now that we know x, finding measure of angle QTR is going to be easy. So x is 7, so QTV is going to be 20 times 7, which is 140. And then we can see that that's going to be supplementary to the angle that we want. So all we have to do is take 180 minus the 140 that we have, and we get 40 degrees for the measure of angle QTR. Just like the endpoints of a line segment cut out a piece of a line, a central angle separates a circle into two parts, each of which is an arc. The measure of each arc is related to the measure of its central angle. A minor arc, like arc AC, is usually named only by the two endpoints. The measure of the central angle is less than 180, so in this case it was 110. A major arc is named by the letters of the two endpoints and another point on the arc, so something in the middle like an angle. So 360 minus the minor arc is greater than 180. So in this case, our major arc is 300. And then of course the semicircle is half the circle. So it's named by the letters of the two endpoints, again, just like the minor arc, and another point on the arc, just like the major arc. So yes, 360 divided by 2 is 180. So both ways, yep, it's always going to be 180. Found typo in the book. I think they meant that second one to be measure of arc JKL. In the same or in congruent circles, two arcs are congruent if and only if. Remember from earlier in the book? That's our if and only if abbreviation. Their corresponding central angles are congruent. So that means we could turn it around. We could say the converse, and that would be true also. So if two arcs have corresponding central angles, congruent central angles, then the arcs are congruent. And then following on that theorem's heels comes the postulate, the arc addition postulate. If the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So in this situation, listed in circle S, arc PQ plus the measure of arc QR all together. Trying to be fancy, red and blue make purple, makes arc PR. They named it PQR, but it's a minor arc. I would just call that arc PR. And here the book is scolding me out. It says, do not assume that because an arc is named by 3 letters that it is a semicircular major arc. You can also correctly name a minor arc using 3 letters. Haha, they just made their point. Arcs of a circle that have exactly one point in common are adjacent arcs. Like adjacent angles, the measures of adjacent arcs can be added. In circle P, the measure of angle NPM is 46 degrees. Segment PL bisects angle KPM, and segment OP is perpendicular to segment KN. Alright, so far I can see KN is a diameter, so that makes KON a semicircle. If we already know this is 90, all I have to do to find OK is take 180 minus 90, and I get 90 for the measure of arc OK, because the measure of the central angle is the same as the measure of the arc. Okay, same diagram. Now they want us to find the measure of arc LM. Now we already said that KN is a diameter, so arc KLN is a semicircle. So I can write an equation, 2x plus 46 equals 180. And all I need to do is subtract 46 from both sides of my equation. We have 2x equals 180 minus 46 is 134. And divide both sides by 2. And we get x equals 67. And that was the measure of arc LM. 67 degrees. Okay, now they want us to find the measure of arc. It's going to be a major arc, J, K, O. So the only thing that I don't want is this arc JO. So if I knew what that was, I could subtract it from 360. Well, it's not too bad to get, because if angle MPN is 46, then angle KPJ also has to be 46, because they are vertical angles. And we said in part A that angle KPO was 90, so I'm just going to subtract 90 minus 46, and I get measure of angle JPO is 44. So now all I have to do to get measure of arc JKO is take 360 minus the minor arc that I don't want, and what I have left is my answer. So 316 degrees. The graph shows the percent of each type of bicycle sold in the United States in 2001. Find the measurement of the central angle representing each category. List them from least to greatest. Well, the least is going to be the one with the smallest percent, followed increasingly up. Now, I hate to give my age, but I'm gonna. Back in the day, before technology, this used to be a big deal because we would take 0.07 times 360 is 25.2 degrees, do our very best to measure a 25-degree central angle so we could construct a circle graph. Seems a little bit ridiculous to do by hand now with nice technology we have. Is the arc wedge named Youth, which was 26%, equal to the combined wedges for other and comfort. Well, not quite. 26 does not equal 28. You could also add the angle measures, and you know what? They're not the same either. So that's a big no. Here's a formula you definitely want to write down. It's a proportion. So we have part over whole, so degree measure of an arc compared to degree measure of the whole circle equals part over whole, so the arc length over the whole circumference. If we do cross products there, 2 pi r, of course we know is circumference, so if we multiply both sides by c, we're going to get this handy dandy formula. A over 360 times c equals L, which is arc length. In circle B, the diameter AC is 9 and measure of angle ABD is 40 degrees. Find the length of arc AD. So we've got our part of our whole, so 40 over 360, which would make a lovely percent, would it not? Times circumference, which is pi times diameter, so 9 pi. And we type that in the calculator, so now it becomes approximately. Oh no, that was kind of novel. Once I cancel everything out, it is exactly pi. So that means it would be approximately 3.14 units. They didn't give us any. What you need to know, the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. And the measure of each arc is related to the measure of its central angle. The length of an arc is proportional to the length of the circumference.